All right, so in this example, we're going to be solving a trigonometric equation. That is an equation that has trig functions in it, and we have to find the angles that make it work. First of all, I'm going to go ahead and draw out my unit circle, as I will definitely be needing it for this problem. So let me go ahead and do that. Okay, so now that I have my unit circle, I'm going to go ahead and draw out the equation, or write out the equation. So it is 2 cosine squared of theta minus 1 times 2 sine of theta minus the square root of 3 equals 0. So we need to go ahead and solve this equation. One thing to recognize is that whenever you have multiplication going on, if either one of these individually were to equal 0, then the whole equation would equal 0, right? If this was 0, then regardless of what number's over here, 0 times anything is still 0. Likewise, if this was 0, any number times 0 would be 0. So I can take these individually and solve them. So I'll have the first one over here equal to 0, and then I'll have this one over here. Okay, I'm going to go ahead and solve this one first. So I'll add 1 to both sides, and then divide by 2. And so I get cosine squared of theta equals 1/2. Well, to solve this, I'll have to take the square root of both sides. So I'll get cosine is equal to, and remember, whenever you do a square root, you have to do plus or minus. This is plus or minus the square root of 1/2. That's the same thing as if I do the square root of the top and the bottom separately. So I'll get plus or minus 1 over the square root of 2. And then if I were to rationalize this by multiplying top and bottom by root 2, I would get plus or minus root 2 over 2. So what I need to do is I need to find every angle theta so that when I plug it into cosine, I get either positive or negative the square root of 2 over 2. So for pi over 4, cosine of pi over 4 and sine of pi over 4 both give me square root of 2 over 2. So I know one of my angles is going to be pi over 4. Now to find the rest, I just need to find the other angles. So one thing I forgot to do was to label what the signs are going to be around here. So I'll do that right quick. You can remember this by all students take calculus. And this just means that all the trig functions are positive here. Here sine is positive, here tangent is positive, and here cosine is positive. So I've got positive root 2 over 2 from pi over 4. Another place where cosine is positive is down here. If I had a reference angle right here of pi over 4, it tells me right there cosine's positive here. So my other angle is 7 pi over 4. That gives me the positive root 2's over 2's. But notice I've got or minus. Well, so I'm also going to have this one over here, 3 pi over 4. That gives me a negative root 2 over 2. And that gives a reference angle of pi over 4 right here, if you were to drop it down. And then I've also got this one over here, 5 pi over 4. So just from the first one, I've got 4 different angles that would work. Pi over 4, 7 pi over 4, 3 pi over 4, and 5 pi over 4. All of these, if I plug them into cosine, I get square root of 2 over 2, which if I square it, is going to give me 2 over 4. The 2 reduces, so I get 2 over 2, which is 1. 1 minus 1, 0. All those angles do that. Now, we want all the angles that work for this whole expression, so we're also going to find the thetas that make this equal to 0. So let's go ahead and solve that. So first I'll add root 3 to both sides. So we get 2 sine of theta is equal to the square root of 3. Now I'll divide both sides by 2. So I get sine of theta is equal to the square root of 3 over 2. And now I just need to find all the angles that make that happen. Well, in the first quadrant, for sine, the thing that gives me square root of 3 over 2 is pi over 3. So sine of pi over 3 is the square root of 3 over 2. So that's my first angle. Now I need the other angle that gives me a positive square root of 3 over 2. Well, using this right here, ASTC, this area right here is the other place where sine is positive. And remember, I want the reference angle to match. So that right there is pi over 3. So over here, I want an angle of the same size, which would be in there. And that corresponds to 2 pi over 3 right there. Since this one is only positive square root of 3 over 2, those are my only two angles. If I had a plus or minus, I would also find the angles that give me negative root 3 over 2, which would be right here. But since this is positive, I don't want those angles. Those will not give me 0, only these will. So your final answer would be all of these angles. When theta is pi over 3, or 2 pi over 3, or pi over 4, or 7 pi over 4, or 3 pi over 4, or 5 pi over 4, all 6 of these angles, if you plug them into this equation, are going to equal 0. In other words, they'll satisfy it. They'll do what it's asking you to do, that is, make this equal 0. So there we go. Using the unit circle, we're able to find all the angles after we solve these algebraically that cause cosine to equal root 2 over 2, positive or negative, or sine to equal root 3 over 2. And that is this example.